Hi, you are in a staring contest right now. Not with me. With every other human you've ever met. Every time you decide whether to text back immediately or wait so you don't look desperate, whether to split the bill or pretend your card doesn't work, whether to trust your business partner or quietly plan your escape. That's game theory. You've been playing it your whole life. You just didn't know it had a name. Now you do. You're welcome. And also, I'm sorry, game theory is the mathematical study of strategic decision-making, which sounds boring until you realize it explains war, evolution, why your coworker steals your lunch, why countries build nuclear weapons they never plan to use, and why you and your roommate have been passive-aggressively not doing the dishes for 3 weeks, waiting for the other one to break first. It's everywhere. Let's get into it. First, what even is a game? Not Monopoly. Well, actually, yes, Monopoly, but also everything else. In game theory, a game is any situation where the outcome for one player depends on what other players do. That's it. You, another person or entity, a set of choices and consequences that depend on everyone's moves simultaneously. Simple, terrifying. Every game has 3 things: players, the decision makers, strategies, the choices available to each player, and payoffs, what each player gets depending on the combination of choices made. Put those together, and you have a game. Could be 2 kids deciding whether to tattle on each other. Could be Apple and Samsung deciding how much to spend on R&D. Same structure, different stakes, same math. Now let's talk about the most famous concept in game theory, the one that launched 1,000 economics papers and 1 Russell Crowe movie, the Nash Equilibrium. Named after John Nash, a mathematician who was a genius, had schizophrenia, won a Nobel Prize, and died in a taxi. Life is not a fair game. But his idea was brilliant. A Nash equilibrium is a situation where no player can improve their outcome by changing only their own strategy, given what everyone else is doing. In other words, everyone is doing the best they can given what everyone else is doing, and nobody wants to change. It's a stable point. Not necessarily a good point, just stable. Here's an example. 2 coffee shops open on the same street. Both decide to price their lattes at $5. If one drops to $4, they get more customers but make less per cup. If the other raises to $6, they lose customers. So both stay at $5, not because $5 is perfect, but because neither can unilaterally do better by moving. That's a Nash equilibrium. Welcome to capitalism. Enjoy your overpriced latte, but the real gateway drug into game theory is something older and more dramatic. The prisoner's dilemma. 2 criminals, arrested, interrogated separately, no communication. Each gets to choose, stay silent or betray the other. Here's the payoff matrix. If both stay silent, both get 1 year in prison. If one betrays and the other stays silent, the betrayer goes free, and the silent one gets 10 years. If both betray each other, both get 5 years. Now think about what you'd do. You don't know what your partner is doing. If they stay silent and you betray, you walk free. If they betray and you stay silent, you rot in prison for a decade. So no matter what they do, betraying seems better for you personally, and they're thinking the exact same thing. So both betray, both get 5 years. Even though if you'd both just kept your mouths shut, you'd only get 1 year each. That's the tragedy of the prisoner's dilemma. Individually rational behavior leads to collectively terrible outcomes. This isn't just a cute math puzzle. This is nuclear arms races. This is companies dumping chemicals in rivers, because if they don't, their competitor will, and they'll both suffer anyway. This is why group projects always have that one person who does nothing while everyone else panics. Rational, infuriating, mathematically coherent. Okay, but here's where it gets interesting. What if you play the game not once, but repeatedly? What if you and your criminal partner are going to be in this situation again and again? Now, betrayal has consequences beyond today. Now reputation matters. Now the future matters. This is called the repeated game, and it changes everything. When you play the prisoner's dilemma over and over with the same person, cooperation can emerge. Because if you betray me today, I can betray you tomorrow, and we both know that. So suddenly staying silent makes more sense. Not out of trust, out of math. The shadow of the future forces cooperation. This is why long-term business relationships work better than one-off transactions. Why countries with ongoing trade ties are less likely to go to war. Why your landlord fixes the heat faster when you've been a good tenant for 3 years. Cooperation isn't idealism. It's just good strategy when you're playing the long game. Pun intended. Now let's talk about something that sounds simple, but breaks people's brains. Dominant strategies. A dominant strategy is one that gives you the best outcome regardless of what your opponent does. No mind reading required. No guessing. Just one move that beats everything else on the menu. In the prisoner's dilemma, betrayal is a dominant strategy. Doesn't matter what the other person does. Betraying is always better for you personally. When dominant strategies exist, rational players use them, and when both players have dominant strategies, the Nash Equilibrium falls right where those strategies intersect. Neat, clean, and often mutually terrible. But not every game has a dominant strategy. Sometimes, the best move depends entirely on what the other player does. Which means you have to think about what they're thinking, which means they're thinking about what you're thinking. Which means you're both standing there thinking about each other thinking forever, which is also known as dating. Enter the Minimax strategy, used in zero-sum games, where your gain is exactly my loss. Chess, poker, most competitive sports, and every argument about who gets the armrest on a plane. In a zero-sum game, the Minimax strategy says, assume your opponent is perfectly rational and will always choose the move that hurts you most. Given that, choose the move that minimizes your maximum possible loss. You're not trying to win big. You're trying to not lose catastrophically. It's the strategic equivalent of wearing a helmet. Not exciting. Very smart. This is how chess engines think. Every move calculated against a perfectly adversarial opponent, making the worst possible move for you. The result is a kind of cold, surgical play that's nearly impossible to beat. Also, deeply unsettling to watch if you've ever played a computer in chess and had it quietly dismantle your entire life plan in 11 moves. Now let's get weird, because game theory gets weird. Let's talk about mixed strategies. Sometimes the best strategy is to be unpredictable. Randomize your moves so your opponent can't figure you out. Penalty kicks in soccer. The kicker can go left or right. The goalkeeper can dive left or right. If the kicker always goes right, the goalkeeper dives right every time and blocks it, so the kicker mixes it up. Goes left sometimes, right sometimes, no pattern. And the goalkeeper does the same. Neither can predict the other. Neither should. The optimal strategy is a specific probability distribution over your choices, not a fixed move. In penalty kicks, the math actually works out to roughly 60-40 in favor of one side depending on the kicker's dominant foot. Soccer clubs have hired actual game theorists to figure this out. Your national team might have lost a World Cup because someone ignored a Nash Equilibrium. Let that sit. Let's step back and look at something even more unsettling, the tragedy of the commons. First described by ecologist Garrett Hardin in 1968, but the logic is pure game theory. Imagine a shared pasture, multiple farmers. Each farmer can graze their cows there freely. Now each farmer thinks, if I add one more cow, I get all the benefit. But the cost of overgrazing is shared by everyone, so individually, every farmer adds more cows, and eventually the pasture is destroyed, everyone loses. This is climate change. This is overfishing. This is every buffet where people pile their plates because someone else will deal with the food waste, and the restaurant will somehow survive. The commons gets destroyed not because people are evil, but because the incentive structure makes individual rational behavior collectively catastrophic. Same structure as the prisoner's dilemma, but with more cows and more existential consequences. Solutions? Either privatize the commons so individuals bear their own costs, or regulate it so the rules change the payoffs. Or apparently, just wait and see what happens. We're currently trying that third option with the atmosphere. Results pending. Okay, new game. Coordination games. These are games where the problem isn't that cooperation is hard. The problem is just figuring out which version of cooperation everyone will land on. Two cars approaching each other on a road. Both need to pick a side. If both go left, fine. If both go right, fine. If they go different directions, catastrophe. The payoff is the same either way. Just pick the same thing as the other person. The equilibrium isn't obvious, it's just a convention. Which is why every country picked a side and stuck to it. Driving on the right in America. Driving on the left in Britain. No reason either is better. Just that everyone agrees on one, and the agreement itself is the value. This is why QWERTY keyboards still exist even though there are objectively better keyboard layouts. Why VHS beat Betamax. Why everyone uses PowerPoint even though it's responsible for more boring meetings than any other technology in human history. Not because these things are best, because everyone else is using them and coordination is more valuable than optimality. Standards are Nash equilibria. You're stuck in them whether you like it or not. Let's talk about Schelling Points. Named after Thomas Schelling, Nobel Prize winner, and genius at thinking about how humans coordinate without talking to each other. A Schelling point is a solution people tend to converge on naturally without communication because it's salient, obvious. The one thing everyone would think of, classic example, you're in New York City, you have to meet a stranger, no phone, no prearranged location, where do you go? Most people say Grand Central Station, noon, not because it's agreed upon, because it's the most obvious place at the most obvious time. The Schelling point Schelling actually did this experiment. Most people independently converged on the same answer. Humans have this remarkable ability to find shared focal points through shared context and culture, which means coordination isn't always about formal agreements. Sometimes it's just about finding the obvious move and trusting that the other person is finding it too. It's beautiful. It's also why every flash mob in history starts at a clock tower or a fountain. Now a quick detour into something dark. Nuclear deterrence. Mutually assured destruction. MAD. An acronym so perfect it was obviously chosen on purpose. During the Cold War, the US and Soviet Union both had enough nuclear weapons to destroy each other several times over. And this paradoxically made both sides safer. Because if you attack me, I destroy you. And if I attack you, you destroy me, so neither of us attacks. The equilibrium is peace through mutual threat of annihilation. Lovely, this only works if both sides believe the other will actually retaliate, which means the threat has to be credible. Which is why countries spend enormous amounts of money on weapons they genuinely hope to never use. It's the world's most expensive bluff that has to be absolutely not a bluff. Game theory built the nuclear age. Game theory also explains why we're all still here. Uncomfortable but true. And then there's signaling. In game theory, signaling is when you take an action not because it's directly useful, but because it sends information to another player about who you are. Why do luxury brands make bags that cost $10,000? Not because they're $10,000 better than a $200 bag, but because buying one signals something. I have resources. I make a specific kind of choice with those resources. Interpret that how you will. The signal only works because it's expensive. Cheap signals are worthless because anyone can fake them. Expensive signals are credible precisely because not everyone can or will send them. This is also why universities exist in their current form. A Harvard degree isn't just about what you learned. It's a signal. You were selected, you survived, you're the kind of person who can do that. Employers don't need to evaluate you from scratch. The credential signals. Whether it signals the right things is a different and much longer argument that you should have with an economist at a party. So what have we learned? Game theory is the science of thinking about thinking about thinking. It tells us that rational individual choices often produce collectively terrible outcomes, that cooperation can emerge not from trust but from repeated interaction and long shadows of the future, that sometimes the best strategy is to be random, that coordination is often more valuable than optimization, that threats only work if they're credible, that signals only work if they're costly, and that you have been playing these games your entire life without knowing the rules. Knowing the rules doesn't guarantee you win, but it means you stop being surprised when you lose. And occasionally, just occasionally, you'll sit across from someone in a negotiation, a relationship, a meeting, a text conversation, and you'll see the game clearly for the first time. You'll see the equilibrium. You'll see the dominant strategies. You'll see where cooperation makes sense and where it doesn't. And then you'll make your move. This took an embarrassing amount of time to make. If you learn something and want more unhinged academic content delivered at an irresponsible pace, the like button is just sitting there, doing nothing. Like your strategy before you learned game theory.